Hi, 7th graders. We're on lesson 6-3, which starts on page 316 in your textbook. Our learning targets are finding the sum of the interior angles of a polygon and finding the measures of an interior angle of a regular polygon. So if we think of common polygons that we know, common shapes that we know, so we can look at a triangle. We know that there's 3 sides in a triangle, and the number of triangles in a triangle is 1. So let me get my... And the sum of the angle measures, so we know that the measure of the 3 angles, the sum of the 3 angles in a triangle equals 180 degrees. And since there's one triangle in a triangle, then basically it's just 1 times 180, and it would be 180 degrees. Let me make sure I do my little degrees symbol. Okay? So if we look at a quadrilateral and we break up our quadrilateral into triangles, we can see that with one line going through, my line should be a little better, but it breaks it up into 2 triangles. So the number of triangles in a quadrilateral then is 2. And then the sum of the angle measures, so we know that we can look at this triangle and these 3 angles have to be added up to get to 180 degrees, as well as this triangle right here. This angle plus this angle plus this angle equals 180 degrees. So we have 2 triangles and both of the triangles equals 180 degrees. So that means that the sum of all 4 of the angles in the quadrilateral then would be 2 times 180, which equals 360 degrees. With my little degree sign. Okay, so then if we look at a pentagon that has 5 sides, we can break up a pentagon into, let's hope I can get my lines better, into 3 triangles, as we can see right here. So then we can add in that there's 3 triangles in a pentagon because we have 1, 2, 3, and same as the quadrilateral, each triangle, the angles add up to 180 degrees. So now we have the sum of the angles in a pentagon would be 3 times 180, which equals 540 degrees. Okay, so we see a little pattern here. Hexagon, we can guess that since we can see a pattern here, 1, 2, 3. So before I even draw my lines, I can guess that there's going to be 4 triangles. And if we look really quick, if we start at one of the angles, it doesn't matter where you start from, you still would get the same amount of triangles. And we just go to all of our other vertices. And we see that there's 4 triangles. So hexagon has 4 triangles, so we would go 4 each triangle times 180 degrees because each triangle, remember, adds up to 180 degrees. And then the sum of all the angles in a hexagon would be 720 degrees. So if we look for a pattern in our formula here, we can see that, because if we want to skip down and we want to figure out, well, what can we do to figure out the formula for n number of sides, or for an n-gon it would be called? Okay, well, we can see the number of sides is 3. Let's change our color here. And we're taking 1 times the 180, because for every 3, or for 3 sides, there's a triangle. For the number of sides with 4, then we're taking 2 times 180. If we have 5, we're taking 3. So if we look and we just compare this number of sides and the number of triangles, basically, or it's the number that we're multiplying by 180, we can take this number and subtract 2. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So if I go way down to my n, I know that I can take n minus 2, and whatever that number is, we'll multiply it by 180. So that brings me to my formula, the interior angle sum of a polygon. So let's write this right here. N minus 2, and then we would multiply it by 180 because it's however many triangles times 180. So our interior angle sum of a polygon, that means that what we were just figuring out, all the angles inside a polygon added together is the interior angle sum. So for a quadrilateral, it would be this whole angle plus this whole angle plus this whole angle plus that whole angle. So the formula then is, we would say S for the sum equals n minus 2 times 180. Our parentheses means that it is times, but if it helps you to remember, we can always put a multiplication sign in between there. Okay, so however many sides there are, you're going to take that number, subtract it by 2, and then multiply by 180. So if we have a decagon, let's do an example quick. If we have a decagon, we would take 10 minus 2, and then we would multiply it by 180. Oops. And we would get 10 minus 2 is 8 times 180 equals 1,440 degrees. Okay? A regular polygon is when all sides and angles are congruent. Congruent means the same. So a regular polygon is when all the sides and angles are the same. So if we want to find the measurement of one angle in a regular polygon, we would first find the sum, and then we would divide by the number of sides. Okay, so remember, up here, our formula, right here, is to find the sum of all the angles. Okay, a regular polygon has all the same, all the angles are the same. So now this is to help us find the measurement of one of the angles. So step 1 is to find the sum. So let's do our example here. Find the measure of one interior angle in a regular hexagon. Okay, hexagon, remember, has 6 sides. Okay, so step 1, we're going to find the sum, which is exactly what we did right up above. So we're going to go 6 minus 2 times 180, and we get 6 minus 2 is 4 times 180 equals, 4 times 180 equals 720 degrees, which I know we figured out in our table up above. Okay, so we know the sum of the angles is 720 degrees. Because all of the angles are the same, then we would take the our sum, which is 720, and we would divide it by 6 because there's 6 angles. So then we would go 720 divided by 6. Bring that up a little. Equals, yeah, this is totally off, sorry. And then we go 720 divided by 6, and we get 120. I'm just going to write it so it's all on the same. 120 degrees. So each angle is 120 degrees in a regular hexagon. Okay, so let's do one more together, and then I want you to do 2 on your own. So we want to find the measure of one interior angle in each regular polygon. Okay, so for an octagon, our first step is to find the sum. So we're going to go 8 minus 2, because there's 8 sides. 8 minus 2 times 180. So we get 6 times 180 equals 1,080 degrees. That was our first step. And now our second step is to take 1,080 and divide it by 8, because there's 8 angles. 1,080 divided by 8, and we get 135 degrees. So each angle in an octagon is 135 degrees. Okay, pause me for a second and do a heptagon and a 20gon. So a heptagon has 7 sides, so we would take 7 minus 2 times 180. We always want to put it in parentheses so we know the order that we're going. So then we have 5 times 180 equals 900, and then we take 900 divided by 7, and we get, we're going to round it to the nearest tenth, so we get 128.6 degrees. This should have been an equal sign. Okay, and then for our 20gon, we have 20 minus 2, which is 18. So 18 times 180, we get 3,240. We divide it by 20, and we get 162 degrees. Okay, make sure you go on to NICU and do the 6-3 NICU quiz. You can always go back and rewatch the video, and you can always look in your textbook as well if you have questions. Have a super evening.